This is a production of Cornell University.
So this is our 5th year of doing small plot grain and fiber variety trials, I believe. And Luis is a relatively new student in my program pursuing his PhD. I think if you were here last year, you heard Luis talk about trials. He's going to tell us about the fiber plots that we're standing in right here, and maybe a little bit about the dual purpose plots that don't look all that great.
Well, thank you, Larry. First of all, who is wearing hemp fiber? That's disappointing. I am wearing one, 100% hemp fiber. So with that in mind, oh, you too? So with that in mind, I would like to pass this around. These are samples of These are samples of hemp fiber and hemp hurd. So I would like for you guys to take a look at it. Pretty much this is what we will get from this field after we harvest, we red, and we decorticate. So as Larry mentioned, there is an interest in the market for fiber and grain production. So we need to find cultivars that can fulfill such demand. So one efficient way to do that is with small plot trials, like the one that you're seeing right now. So here we have 12 cultivars that are replicated in 4 times in 30 square foot area. We have 5 cultivars from France and 5 cultivars from China and 1 cultivar that was developed by the Cornell breeding program. So one thing that you know is that, well, okay, the small plot trial will help you estimate the yield, right? So that's great. That can help you fulfill a demand and great, but how about the quality? And most importantly, what is quality, right? So one important thing that we need to know is how much of that can be used for textile, aka the bast. How much of that is the hurd, right? So if you have access to the handout, you can see on the back that we have results from last year, a strip trial if you were here, and we observed that some cultivars were able to develop or to yield about, let me see, compared to the imperial system, that would be 4.5 to 9 US tons per acre, if I'm not mistaken, and whereas others did not exceed 2.5 US tons per acre, right? So there is a considerable comparison across cultivars. Now, then when we talk about yield, then we have to harvest, then we let them red to a specific point for a proper decortication, right? And we observe that these high yielding cultivars develop about 2 to 4 metric tons per hectare, which it would be 1 or 2 US tons per acre. So that's pretty good, right? Now, the next challenge is it hot? Does it go hot, right? So when we sample this, we observe that 2 of those high yielding cultivars exceeded the 0.3% THC threshold. So that is very important, right? Because we can have a high yielding cultivar, but then your entire field will be completely destroyed because it exceeds the threshold. So that is one breeding objective that we have, and we want to emphasize that, you know, in these kind of outreach activities, right? So in the handout, you can see one of the tools that we use for quality assessment, and that is the use of the decorticator. In the back, you can see the machine that we use. This was a machine, thanks to Heather from Lithuania, that helped us decorticate all this material. Now, we talk about quality. Another important associated agricultural practice is the stand density. And that is that we need to ensure a high planting density to have a thin stem, because it is believed that, or what we have seen actually, is that the lower the planting density, the higher the lignification in the stem, which will in turn mean that you have more hurd than bast in percentage, right? So why am I saying this? Well, the target planting density of this trial was 30 plants per square foot. However, after 3 weeks of planting, we noticed a strip of death, as I like to call it. A line perpendicular to the field was after 3 weeks after planting, we observed that the plants were dying slowly and slowly. So what happened was that we applied this herbicide right after planting, pre-emergent herbicide, and there was some overlapping in the middle. And when that happened, there was obviously a double application of this herbicide whose active ingredient was pendimethalin, inhibits cell division, right? So the symptoms of this are chlorosis, necrosis, reduction of the stand count, obviously, stunted growth. Larry is pointing out to that. But in addition, the plants that survive had this bulbous symptom at the base of the stem. So that is actually one of the symptoms of the exposure to pendimethalin, which is the active ingredient of this herbicide that we sprayed. So there's something to keep in mind. One thing that we are realizing is that herbicide might not be as good because our stand count is going down. So we compensate for the poor seed quality, germination, you name it. But then in the field, we don't get that stand count. So we see that there is an extraneous factor that we were not considering, and now we have to consider, which is the decimation of the stand count by this herbicide. I have no time. Okay, we're good. Yeah. So in addition to that, we are also testing the dual purpose aspect of hemp, or grain, if you want to call it as well. So for that, we decrease the plant intensity. In this case was 12 plants per square foot, and that you can see over there. However, George already mentioned this, June was too wet. We couldn't plant on time. And actually that part of the field was planted about a month after this field. However, some of them are looking pretty good. And one thing that I will point out is that there is another cultivar that we developed in our program that is planted over there, and I am very happy to say that this is the cultivar that is thriving compared to the other ones. So it's one of the cultivar starts with a GVA letter system, and the other one will be the same letter system, right? That are actually on the north end of each plot. So please walk around, look at the plants, don't kill them, please. I need to harvest. And please, if you have any questions. Yeah.
For your seeding rate, why did you choose fiber typically is a heavier planting density, but why did you choose this heavy of a planting density?
Yes, so the question was, why did I choose this heavy planting density for these cultivars? So for this, one thing that we were considering for this was the percentage of emergence. One thing is having germination in a paper towel, and quite another is having germination in the field. So we accounted for 70% emergence, just an arbitrary number, to have as much material in the field as possible. Obviously, some of that material may be lost due to self-thinning. If you guys are familiar with that, is the plants, the cultivar itself will shade out all the plants, right? But the idea was to ensure as tight planting density as possible to have the greatest quality that we can get. So you can barely, I mean, because you have the labels, you can see which cultivar is which, but they are very tightly planted and very close to each other, because we want to simulate a fiber production system that will be a larger scale. Any other questions?
What drill did you use?
Great question. What drill did we use? We used a, Jamie, help me out. I think it was a 3.5 foot wide planter, right? And I don't recall the inner row spacing. Was it 7 inch?
Yeah, it was
7.5 inch spacing in rows.
It was a cone seeder.
Oh, sorry, a cone seeder, yeah. So the cone seeder facilitated us to actually plant cultivar after cultivar in one pass. Any other questions?
Talk about stem diameter.
Yeah, so last year when we were planting the steep trial, I noticed a very interesting aspect of the fiber hemp cultivars, and that is that certain fiber cultivars, when planted at lower densities, were pretty much trees. They had a very wide stem diameter, while other cultivars, I think European cultivars, did not have such wide stem diameter. So here you can see a decent stem diameter. What is colloquially mentioned is a pencil thin stem for fiber, right? So like this would be ideal, but it's also ideal because we planted it at very, tight planting density. we did an analysis in regards to correlation of stem diameter with bust. Sorry, with what was it? Oh, stand count and stem diameter. So what we noticed is that for some cultivars, the stand count did affect the stem diameter, but for other cultivars, that wasn't so much the case. So there is some genotypic differences in the response to planting density, something that we can explore and we can definitely exploit.
So if you're harvest, if you're going to harvest fiber for textiles, this is the perfect size, pencil diameter. That's what they want. That's going to maximize your yield of high quality bast fiber. But there are a lot of things we can do with hemp. You may be more interested in the hurd for construction materials, or to mix in to make a bioplastic mix. And in that case, you probably want to go for the big plants, the big diameter plants, because that's going to maximize your hurd yield. But the bast fiber bast fiber quality will suffer in those plants. And you also have to be able to harvest it. My colleagues at North Carolina State have been working a lot with the Chinese cultivars. Those tend to, when they are in, as Luis said, when they're planted in low density, you tend to get big stem diameters, and they got 1 inch, 1.5 inch, even 2 inch diameter stems at the base, which choke the sickle bar mower. So you have to be able to harvest it. Are you done? Are we moving on to Jamie?
Sorry. How are you determining your harvesting timing? Because when you're talking about quality after it's been decorticated, harvest timing is. How are you determining your harvesting time?
So the question is, how do we determine harvest time? So just to add on to whatever Larry said, is that the stem diameter not only affects harvest, but also the decortication. Your decorticator may be clogged when you have a stem diameter that is wider than 1 inch. So it will be very difficult to remove the bast, something to keep in mind. So the harvest time actually was based on flowering. So one interesting thing about flowering, I'm glad you asked this question, is that in some populations, actually a population that we are going to harvest for the demo, we noticed that about 15% of those individuals flowered, but that is stopped for like 2 weeks. So we can naively say, oh, let's harvest it because it's flowering. Like, that's the optimal time point. After that, there's lignification. But not the entire plot was flowering. So what we are doing is estimating 50% of the individuals flowering for the harvest time. Once we reach that point, we can harvest the following week, so then we are sure that everything is flowering and we can rule out segregation in the population. And with that, I would like to introduce you Jamie Crawford.
Hello, everyone. So we planted our very first plot trials for grain and fiber in 2017. So this is actually our sixth year. Pretty exciting. And then in 2000, and for those trials, we harvested the plots with a small plot Elmaco combine. In 2019, we started in collaboration with how many other universities are involved in the multi-state program. There are 14 other locations that are planting the exact same trial as you see down there. So you will see some cultivars that didn't do very well here that may be outstanding in other locations. So those are University of Vermont and Michigan State are some of the other northern locations, but then it's also at Louisiana State. So we've got a huge difference in latitudes for these cultivars. And so in 2019, we had a multi-state trial and a trial that we managed the way we always had. And we did that again in 2020. And throughout time, our trial methods became closer together. So now we just have the one trial that we're managing all in the same way. The big difference, I think, for the management is before we would use the plot combine, like I mentioned, for the grain harvest. But while it's a very excellent combine, the cutter bar is only able to go up to 2.5 to 3 feet from the ground. So we weren't really able to give people the dual purpose information that they would like, because even the super tall cultivars were cut off for grain at 2.5 to 3 feet. So now everything's being harvested in quadrats, and we'll be able to give everyone the fiber yields that they would like, as well as the grain information. So we'll walk through those on the way to the next location, so please find me if you have any questions. Oh, I just want to mention, there are some very excellent hemp cultivars that look terrible in the plots that we were going past. So that is, yeah. So the current conditions that you see here are not representative of the potential of those cultivars. I want to make that very clear.
Why do they look terrible?
I think it was a combination of the weather, being planted the end of June. The herbicide may have had an impact. There were a few of them that were marginal seed lots to begin with. And so Lynn mentioned this morning, if you were in on her talk, that that if the seed lot wasn't great to start, then it was way more susceptible to any of the herbicides. So I think that may have played a role in it. And at this hemp meeting last year, I recommended anyone growing for grain or fiber to do their own germ test. And so I've set up some ragdoll tests to show you what you should see after 2 days in a germ test. And these were just in a Ziploc bag in a sunny window. So it got an alternating warm and cool temperature in the night. And so at the far end of this field, I'll have those set up so you can look. And if you find that your seed lot looks a lot like the bad one, then I implore you, reach out to your seed provider so they can make it right. You do not want to put that in the ground, because even if you have something with 40% germination, it's got other issues than just low germination. You cannot increase that seeding rate enough to make up for that low germ. And so, yeah, so are there any questions before we start walking? Sorry.
Can you just explain to the uninitiated the ideal way of harvesting a dual-purpose plant so that you're maximizing the yield of both?
Well, you'd want to harvest it when it's at about 75%. The grain is, they turn it off. When the grain is about 75% mature, and I didn't think I pushed any buttons. When the grain's about 75% mature, and you want to raise the cutter bar up as high as you can, so you can leave, both for the sake of your combine, which you don't want to have all that material wrapping around inside, and for the amount of fiber that you can leave behind, you want that cutter bar up as high as you can to just take the seed heads off. Okay. Is that good?
Can I add on to that? No.
Yes, please.
So there are a couple of ways that you can do a dual-purpose harvest. We have a stripper header from Formation Ag, which they call clean strip, I believe, that we have mounted on the front of a tractor where the bucket is. So we can raise that stripper header up 6 or 7 feet high. You can drive through the field and then capture all of the grain from the grain heads. And then we have followed behind that with a sickle bar mower and laid the straw down right behind the stripper header. So that's one way. It's a 2-tractor operation then. You have to be conscious of the direction that you're going, so the sickle bar actually is going to come back the opposite way that you went with the stripper header, because the stripper header has sort of leaned the stems over. So we did that last year in some strip trials. It worked quite well. That stripper header is then offloading into a wagon you've got adjacent. The other way is to use a dedicated dual-purpose harvester. There is a machine that is a modified John Deere combine built by the company Hemp. We have one of those Hemp harvesters here in New York. It was brought here by Canopy Growth as a part of their project a few years ago. If you're interested in doing dual-purpose hemp harvest, please come see me, because we are trying to retain that machine here in New York to stimulate the hemp industry in New York, and would like to identify people who can commit to using that Hemp harvester in the future so that we can make a business plan to retain it here. The plan right now would be it would be housed here at Cornell AgriTech, but it would be rented out on an hourly basis so that the owners can recover the cost of that machine.
This has been a production of Cornell University, on the web at cornell.edu.